Hello and welcome again to another Science Vision video. Now in this video we're going to look at the topic of separating mixtures. Now you need to be able to describe techniques for separating mixtures. There's a range of techniques and these are the ones we're going to look at: filtration, simple distillation, fractional distillation, crystallization and paper chromatography. Now in each case we'll describe the process involved and also give you an example when it could be used. Let's start first of all with the most simple, which is filtration. Here we've got a conical flask, a filter funnel. In the filter funnel there we've got some filter paper. Okay. Now filtration depends upon different size of particles in a mixture. The filtrate particles of the filter paper, the residue is left behind. This bit here is called the residue, it's left behind. This bit here is called the filtrate. An example is you separating soluble solid from a liquid. For example, you've probably done this many times yourselves: sand and water. So we had here a mixture of sand and water. In order to get pure water down here, we simply filter it. The sand will become the residue, the water will become the filtrate. Okay, so that's filtration. The second one is simple distillation. Here we've got a conical flask. This is called a delivery tube here, and a little beaker here. Now simple distillation depends upon the different boiling points in the mixture. The lowest boiling point evaporates first and can be collected. Now the technique is used to separate a soluble solid and a liquid, for example pure water from salty water. So you had in here salty water, you would heat it up to the boiling point of water and you collect pure water over here. It's a bit of a crude method. For a more precise distillation we really need to have what's called fractional distillation. Now this can be used to separate two liquids that have different boiling points. So you put the liquids over here, and here you've got a thermometer. Now you can control this very accurately, heating it, the Bunsen burner, watch the temperature. When it reaches the required temperature you take the Bunsen away. So only the liquid with the required boiling point will evaporate, come down. Now this is called a condenser. A condenser has cold water going in here and comes out here, and as it cools this tube here, so the liquid coming down, the gas coming down here, or vapor, will condense into a liquid and drip out down the bottom here. So the technique is used to separate mixtures such as ethanol and water. If you had here a mixture of ethanol and water, ethanol has got a boiling point below, I think it's about 80 degrees Celsius. So as long as you kept this here below 85 degrees Celsius, the ethanol will boil away and condense to a liquid, but the pure water will be left behind. So it's a very good technique here for separating two liquids with different boiling points. Now suppose you want to separate a solid from a liquid, but we don't want the liquid, we just want the solid, and for that we could use crystallization. Now crystallization is used to separate a soluble solid from a liquid when you want to collect the solid. The technique is used to separate mixtures such as salt and water when a salt is required. Okay, so this is an evaporating basin here, or crystallization dish. You'd heat it, the water gets driven away. Before it's all gone, you take the Bunsen burner away and leave this to cool. The last bits of water will evaporate, and in there you'll be left with sometimes some very pretty, beautiful crystals. Okay, that's crystallization. Now the last technique we'll look at is paper chromatography. Now you probably did this very early on in your school career. What you do, you put down here a little dot of ink. You might use Smarties for example, and here's the start line, and what happens is that a solvent travels up through the paper. As it does so, it carries the colours with it, and the colours separate according to their density. Okay, and you actually measure, you can measure how far they go and work out what's called an RF value, which we'll come on to in another video. So chromatography is used to separate, identify mixtures that are or can be coloured. There are other ways you might use this. The technique is used to separate mixtures such as pigments in an ink sample. Okay, you might use this in a basic forensic science experiment to see whose pen was responsible or whatever. Okay, or you could separate out the colours in Smarties. So paper chromatography is the last of our 5 separating techniques. Okay, well thanks for watching and listening. If you want to see more examples of these Science Vision videos, just visit my website at www.sciencevisionvideo.com. Okay, thanks for watching and listening. I'm back with you again very soon.